For this problem, it says use standard enthalpies of formation from the equation sheets or the back of your book or Google. That's a fine place to find these as well. To calculate delta H reaction for this reaction, then draw what's called a reaction energy diagram for each reaction using reaction progress. And well, let's talk about that reaction energy diagram in a minute. So the way this works is, and I think this is the same one we've already done. So we already did this, and so we know what the answer is going to be down here. But we're going to do it a different way now. And this way is going to say, okay, tabulated on a list, which I hope I have here. Oh, my list may be missing. Well, so on our conversion and equation sheets, there is a list. I'm just looking around to see if I can find mine. Oh well, I have to figure this out. So, so there's a list of what are called delta H F values, and they're all in kilojoules per mole. And you can look them up for all of these. And I'm going to look them up on the conversion and equation sheet for this class, which is under the syllabus and schedule sheet. And I will share it. There we go. Let me share my screen. So this is one of your conversion equation sheets. It's on the page after all the constants, and then it's on page 2 has our vapor pressures, and then on page 3 are the delta HF values. And what we're going to do is we're going to, on this list, find all the values for, or each of the values for each of these materials, and then we'll figure out what to do next. So H2S, let me see if I can zoom in here. H2S. H2S is minus 20.6. And O2 is over here, and O2 gas is 0. And H2O gas is right here, and it is minus 241.8. The other reaction we just did, by the way, had H2O liquid here, so that's going to be different. And then SO2 is going to be minus 296.8. And so all I did is I got these values from a table, and I've written them on my sheet here. And the way that you calculate delta H reaction, one of the things I don't talk about too much is this little naught symbol. So naught, which is the 0, means at standard state, but sometimes I have it and sometimes I don't. And either way is fine for this class. So technically it means that these values are at standard state, which means it's at 25 degrees Celsius and 1 atmosphere. But again, we don't really talk about that, although I'm happy to talk more about it if you'd like. Okay, so delta H reaction is, the general formula is going to be coefficients times delta HF naught for products minus coefficients times delta HF naught for reactants. So that's the general formula. Now let's apply it. and I'm going to try and take up as much space as I can here. So coefficient times delta HF for products looks like this. So first coefficient is going to be a 2, and then it's going to be the minus 241.8. And I'll leave out my units here. We'll put them back in at the end though, but just to save space. Then it's plus 2 times this value here. So that's coefficient times delta HF for each of my products. And then it's going to be minus this whole term here, which is going to be coefficient times delta HF for our reactants. Plus 3 times 0, well, we don't really need that mathematically, but I'll put it in just for a sense of completeness. And now we just have to add these up. I will point out to you that there are 2 minus signs here. So this, I'll make that a plus and that a plus, and technically that's a minus, but still it'll be minus 0. And then multiplying all of this out, it's going to be 2 times 241.8 minus plus 2 times 296.8 minus. And now this is going to actually be plus 2 times plus 20.6. And I get minus 1036. And I'll put my units back in. My units for all delta H values are typically kilojoules per mole.
Professor,
Go ahead.
can you walk me through how you did the second part of that formula one more time, starting at 21? I
Yeah,
understand
so
the first portion. If we could just readdress that one more time.
this portion right here. So the product.
Yes, that side of the equation.
Sure. So let's see if okay. So for the product side, you are subtracting so you're subtracting the reactants times their coefficients. So and what I typically do is I just typically write it how I see it. I have a 2 coefficient here, and I have a minus 20.6. And then, so everything in here is added, just like everything was added here. And the way that you typically see this, if this was in your textbook, your Libre text, or from Google, is you typically have this giant, what's called a sigma. And for math, what that means is sum of all reactants. So that's what that giant symbol sigma means. And so I have to do, basically, I have to do coefficient times delta HF for my first reactant plus coefficient times 0, but that's my delta HF for my oxygen. Okay. And so this is what you end up with. And what I said is, so, and you can totally just do it like this. Like you could totally add this up as minus, and then 2 times 20.6 is minus 41.2, and then plus 3 times 0 is just 0. So you can actually totally do it like this, and then show that 2 minuses are a plus, or even if you do it in your calculator just exactly as you see it, and if you put in 2 minus signs, it will make it a plus for you. Anna, I don't know if that's what you were looking for, but please feel free to ask again.
Oh yeah, that was fine. I thought that number was 21 in the beginning, so I was confused with how it got 21. But I realize now that it's just two. So I was just
Got it. Okay.
wondering.
Yeah, no, so good. Any other questions about this?
Yes, excuse me, Professor.
Kristen, go ahead.
Yes, you saw for ethanol, you use 1263. But in this sheet, what we have is negative 1274.4. So which one is correct?
So are you talking about the sheet that I showed with the delta HF values?
Like what you use for the value of ethanol is not the same thing with what you use to solve during the lecture notes.
All right. Let me just show that so we can make sure that. All right, and so here's ethanol. So CH3, oh, C2H5OH.
Sorry, I mean C6H12O6. Carbohydrates. Yeah.
Yes. So this is, let me see. So this number right here.
Yes.
So what do I use someplace else?
Negative 1263 in the lecture video.
Okay. So I apologize for that. These numbers are supposed to be the same wherever I use them. But what happens, Kristen, is when I use different textbooks or different sources, so you said it was, let's see, minus 1263.
62.
62. So, and what you will see is, and I apologize for this, sometimes I use slightly different sources and they have similar but not quite the same values for, so I would say on your exam, when I write your exam, I go directly to this sheet right here and I use these values. And so I will make sure that all the values are correct. What happened is, and I don't know how this happened, but I must have looked at a different textbook when I used this C6H12O6 value. So anyway, Kristen, I apologize for that. It should be the same, but it's a mistake that I made. And you can at least see that they're pretty similar.
Okay.
Yeah. So, and what'll happen is, if you, let's see, another one, I don't know. So every time I change textbooks, some of the values change just a tiny bit, and I missed that one. But I will take a note to update that.
Excuse me, Professor. I have a question.
Yeah, go ahead.
SO3, the one Manal mentioned, it wasn't on the conversion list. I had to check on Google, and I was getting different values, like you said.
But were they all similar, Jumbo? Just not quite the same?
Yes, just not quite the same.
Yeah, I mean, I think so. As much as possible, I try and make everything consistent in this class. But when you go out and you look at values from different scientists, you will get slightly different values. And what will happen is when you add them all up, basically you will get something that is within 1 or 2%. So yeah, so everything works out fine. And if ever there was an issue where that happened on an exam, you would just have to point it out, or I would notice it and we would take care of it.
Okay, so during the exam, are we going to get the same one in the paper, or we might get something different that we have to Google?
So I will double check this, but as far as I know on the exam, you only have things that are on the on that sheet that I showed you.
Okay, thank you.
Yeah. So note C6H12O6 solid delta HF value. Yeah, no, good question. I'm sorry. As much as possible, I try and keep things consistent because I know it can be confusing. But that one slipped through, and you may find other ones.